Okay, we are looking at lesson 3. So the unit for any type of energy is joules. That could be any type. We're going to look at another type of energy today, but joules, just like force, every force is in newtons, every type of energy is in joules. This is the same unit as the unit for work. So joules for work, and joule energy is also measured in joules. So gravitational potential energy is present when the force of gravity has the potential to do work on an object. So if it has the potential to fall, we say that there's gravitational potential energy. If it's like, so the equation for that is mass times 9.8 times the height. That's how much gravitational potential energy something has. Take the mass of the object times its height times 9.8. The unit is also in joules. So when does something have gravitational potential energy? When it is in an elevated position, has the potential to fall above ground zero. All those are the same thing. Okay. When does it not? Is when the object is at ground zero, when the elevation is defined as 0 meters, has a height of 0 meters. What would cause an object to have more potential energy than another? If it is at a higher elevation or if it has more mass. So physics definition of mechanical energy, this is kind of lame, is it's the energy that we care about in terms of physics of motion. It's pretty lame, but just go with it. Mechanical energy is the total amount of energy. The equation for this is the important part. Mechanical energy is equal to kinetic energy plus potential energy. So again, that's mechanical energy is equal to kinetic energy plus potential energy. So in physicsclassroom.com, they call these internal forces. I like to call them conservative forces. So we're going to go with conservative forces, list all of them. We're just going to look at the force of gravity. That is it. Okay, so we're going to call gravity as a conservative force. What is a non-conservative force? Not a conservative force. Everything else. So applied force, normal force, friction, tension, air resistance, all that stuff is non-exertive forces. Okay. So what happens if a non-exertive force does work on an object? What happens causes mechanical energy to increase? What happens when a non-exertive force does negative work on an object? Causes mechanical energy to decrease. And what happens when a conservative force does work on an object? Mechanical energy remains the same. It remains constant. So this is a big slide here, an important slide. The equation that relates mechanical energy and work. So we just talked about how if a non-exertive force does work, it changes mechanical energy. But by how much does it change, the mechanical energy change? Turns out that the work done by a non-exertive force is actually equivalent to how much mechanical energy changes by. This is a big idea, okay? So we want to tie this into kinetic energy and potential energy. So we know that the change in anything is final minus initial. So the change in mechanical energy is final mechanical energy minus initial mechanical energy. So remember that mechanical energy is the sum of kinetic plus potential. So the final mechanical energy is equal to kinetic energy plus potential energy. Okay, so the sum of those two minus the initial mechanical energy, which is the sum of kinetic plus potential. Okay, so that and that. So we're going to take this side and we're going to bring it over because we're going to get rid of this negative sign. Okay, So we're going to bring this over and we have kinetic energy plus potential energy plus the change in mechanical energy is equal to the final kinetic plus potential energy. And then finally, relating what we had up here, down here, we're going to substitute work done by non-exertive force and for change in mechanical. So this is the equation we're going to use a lot. That's a really important equation there. So when is total mechanical energy conserved? If there are no non-conservative forces doing work on an object. So if only conservative forces are doing work on the object, then mechanical energy is conserved. When is the total mechanical energy not conserved? Well, if there's non-conservative forces doing work on an object. So we've all learned, like the law of conservation of energy, like energy cannot be created or destroyed. What does the word conserve mean? Well, it stays the same, remains constant. To save, mechanical energy is just one type of energy of the whole energy as a big picture. So we're just looking at a subset here. So we can lose and gain mechanical energy without destroying or creating energy as a whole. Okay? And that's it.